Everything I know about quantum physics I learned from being a mom. Well, okay, obviously that's BS. A PhD in physics helped. Quantum physics is the physics of matter on very tiny scales, like at the scale of an atom or smaller. It's not like babies know anything about any of that. But watching my own baby figure out the material world was full of insights into its intrinsic logic, also full of insights into the intuitions and assumptions that it takes us years to develop about material reality, and that we end up needing to unlearn to grasp quantum reality. Tiny babies begin their lives having absolutely no idea what's going on with their bodies or their environments, which explains a lot of the crying. For example, babies don't at first understand that some body parts around them belong to them, and some belong to other people. They don't know that the feelings they have are internal to their bodies. For all they know, when they feel like crying, the walls in the room feel like crying too. They also don't understand that people and things continue to exist when you can't see them. All this makes watching babies enormously fascinating and entertaining, if you can get past the sleep deprivation. Watching a baby is watching a person discover their body, discover the very idea of a body, as they discover the material logic of the world around them. Like, one day, they discover they have feet, and those feet move, and you can do stuff with them. And whoa, hands. They have fingers. You can see babies actively working out which aspects of a phenomenon are interior to the body and which are not. A finger bending looks a lot like a ribbon bending, but feeling a finger bend is different from feeling a ribbon bend. This multisensory exploration is part of building the idea of an I, the foundation of a sense of identity. The I has a body, and that body has a boundary, and its senses function as an interface. The process of separating self from world takes time and involves a lot of silliness. Peekaboo games are so exciting for babies. They haven't figured out yet that the world persists when they aren't looking. So, there goes the world again. Can I bring it back? It's amazing how much power we have over reality. The point is that baby play is all about the physical logic of macroscopic bodies and objects. Through play, babies learn that people and things persist even when nobody's looking. They learn that bodies and objects typically cohere into a complete whole, even if they have parts. That whole moves as one through space, even if its shape sometimes changes. Bodies and things take up space and have boundaries. They can be both seen and touched, and often smelled and tasted too. They don't overlap with other things. They don't disappear or reappear, dissolve or reform, pass through other things, or change spontaneously into other things without some kind of explanatory story. For older babies, putting things into other things and taking them out again is endlessly fascinating. This idea, the idea of a container, is a step towards the idea of organizing objects into categories. It functions as a foundation for logic and mathematics. And while children are figuring out the spatial logic of the world, we're also introducing them to language and to pictures, reinforcing and shaping how they begin to think about categories, bodies, and objects, introducing them to methods of representation through verbal labels and visual symbols. But wait a minute. I got to this point in making this video and suddenly thought, the set of pictures I've shown so far is so white. I mean, yes, it's a bunch of pictures of my own kid who is categorized in the human world as white and female like me. So maybe that's just the perspective I have and I should own it. But then I talked about my understanding of my kid's experience, first of all as if I really know what that experience is like, and then as if it generalizes, as if it's universal. It's all full of problems. Not sure how to deal with the overwhelming whiteness of something you're presenting to the world? You know, stick in a token picture of someone who isn't white, right? Yeah. So this is a small friend of mine who would be categorized by the world as black and male. I asked his mom's permission to use this picture, and I said I would try to avoid accidentally engaging in tokenism. So maybe instead I'm non-accidentally employing tokenism to make a point, and probably not very successfully, but the upshot is that I really want to acknowledge the complicated politics of visually representing people. Skin is never neutral. A picture of a person is never just a picture of a person. It's a representation, it's a symbol. Anyway, I'm pretty sure all the stuff I said about babies learning about the world applies to how babies function, regardless of differences like race or sex. But we should ask the question. There are lots of ways that babies could be different that would matter for how they understand matter. And there's also a point to make here that what babies are figuring out about containers and categories and bodies and boundaries, and the way parents train babies to understand labels and representations. It isn't just about blocks and toys. It's also about the definition and politics of human identity. And so, right, we'll get to atoms here in a minute. With all the caveats and complexities, what I really wanted to say about babies is that they typically take a lot of experiential learning to figure out the idea of things, material things, bodies or otherwise. And here's my kid again, who is now 7.5, and for the record, clearly identifies with she/her pronouns at this point in her life, and also for the record has given me permission to use all of these pictures and videos. She knows by now that her mom is really weird, so she doesn't flinch when mom says, "Can I make a video of you drawing a few things for my work?" "All right, fine, mommy, what should I draw?" "Well, first thing, without thinking, draw a chicken." Here's the chicken. I showed it to a chicken. I also showed it to the puppy. Both of them were confused. And really, that makes sense. I can easily recognize this as a drawing representing a chicken. But that's weird, right? It doesn't actually resemble a chicken or really any kind of bird at all. It's a couple of yellow lines on a flat sheet of white paper. Totally unchicken-like. How exactly is it that humans can make sense of something like this? Well, what I want to argue is that what this picture captures, and what this type of picture is about, is the generic thingness of the chicken. The drawing captures ideas about the chicken's boundaries and spatial extent, that it has constituent parts, like wings and legs and a beak, and those parts have a particular spatial arrangement. My kid also picked a marker that was most similar in color to some of her own chickens. Chickens, as things, have properties, like color. And you were wondering about atoms. So here, regard a picture of an atom. Chicken. Atom. Chicken. Atom. So what am I trying to say here? Well, obviously I want to compare these two pictures, kinds of things that they say. You've probably seen pictures like this. And you've probably learned that atoms, like chickens, have parts. A chicken has legs and wings and a beak. An atom has a component called the nucleus, which is spatially located in the center. And it has electrons, which are spatially located around the nucleus. The nucleus itself also has components, called neutrons and protons. And in this sense, both pictures are functioning the same way. They tell us about spatial arrangements and components. And just so that I don't miss the opportunity to make this a little bit like a legit science lecture, here's a reminder that everything around us is made of atoms. Each element on the periodic table, which you might have seen in a chemistry class, corresponds to a different kind of atom, distinguished by a different arrangement of subcomponents. So for example, carbon, which is the basis of living bodies, has a different number of neutrons and protons and electrons in it than helium, which is what I showed before. So bring back the chicken for a second. I highlighted some of the ways that these two pictures are similar in showing the idea that an entity has parts, and those parts have a spatial relationship. But there are some real problems with thinking about atoms or their subcomponents as things in the same way that we might think of a chicken as a thing. First of all, if you've learned some chemistry or physics in the past, maybe you've been told that the electrons are hard to visualize as little dots. Maybe it's better to picture some kind of a fuzzy electron cloud around the nucleus. Well, okay, but what does that mean? Does it just mean the electrons are zooming around so fast that they're just a blur? Well, not really. The thing is that electrons don't obey the logic of macroscopic things. They don't necessarily have a singular place, a singular trajectory through space. They don't necessarily persist in their nature and properties when nobody's looking. All of these statements are central conclusions from quantum physics. They're based on decades and decades of experiments. Atoms and their components genuinely don't follow the logic of macroscopic things. But right now, there's just one aspect of the non-thingness of matter on the quantum scale that I want to emphasize. And to make the point, first I need to tell you, or remind you if you already knew, that the neutrons and protons in atoms also have parts. Those parts are particles with the goofy name quarks. There are a bunch of types of quarks in nature, and they all have really silly names. The ones in neutrons and protons are called up quarks and down quarks. So if you learned at some point that atoms were made of protons and neutrons and electrons, well, that's true, but maybe it's more accurate to say that atoms are made of up quarks, down quarks, and electrons. Quarks and electrons are matter. They have mass. They're examples of what physicists call fundamental particles, meaning that no experiments have ever been able to show that they have any subcomponents or parts. In physics, we generally think of them as essential, basic building blocks. And just to establish some vocabulary, they're also examples of what physicists refer to as quanta, meaning little tiny bits of matter and energy. The word quanta is the plural form of the word quantum, as in quantum physics. Quanta are what quantum physics describes. And one of the weirdest things about these quanta is that according to lots of high-tech experiments, some of which I'll tell you about in a later video, they have no size at all. And really, not just that they're very, very, very small, but that they have no size at all. They are sizeless. What we're saying here, really, is that the things and bodies of the macroscopic world, with their boundaries and interiors and exteriors, are made up of non-things on the quantum scale that don't have boundaries, that don't have interiors, that don't have exteriors. This is a hard concept to get your head around. I mean, in math, we're introduced to the idea of a geometric point, but we usually symbolize it with a dot. In case you can't see it, here's the dot. In math, the dot is meant to represent an abstract concept of something that is infinitely small, that really may not exist in the physical world. Meanwhile, the physical dot that does exist in the world has a size. It has a boundary, an interior, an exterior. So how weird is it that the actual physical entities that we're claiming make up everything, including the dot on the piece of paper, actually genuinely don't have edges, don't have extent? This makes the idea of touch really strange. Surfaces come together, skin comes together. But if you could zoom in, there's no way that anything within the skin of one hand could ever directly contact a thing in the skin of another. There aren't those things. The entities that make up the skin don't have a size. They don't have boundaries. They don't have edges. They don't have anything that we could use to define the idea of contact. In a sense, then, touch is a complete illusion. Electrons in the atoms of my hand never contact electrons in my child's. There is no concept of how a point-like particle could ever contact another point-like particle. And honestly, on a quantum scale, the electrons in my hand never get that close to the electrons in my child's hand anyway, before the pushes that the electrons exert on one another force our skin apart. We really never touch. The sensation of touch is a sensory response to an interaction that is always across a distance. Whenever I think about this, I have the irrepressible urge to push on something solid really, really hard. It's very difficult to grasp that the solidity is an illusion, that no matter how hard I push, there's always space between the atoms in my finger and the atoms in the table, and that nothing in any of those atoms technically even has a surface that we can imagine contacting another surface. So this is a way that this kind of picture is really different from this kind of picture. The ideas of objects having solidity and boundaries, clearly defined interiors and exteriors and parts, those ideas are all about macroscopic experience, not about microscopic reality. I said to my kid, "Okay, quick, draw love." And here's what she drew. Pretty sure that the chicken and the puppy won't understand this one either, nor would a baby. But I get it, and I'm kind of blown away by the sentiment. I'm blown away also by how much a human child needs to learn in order to be able to operate within the human world of language and symbols that gives this kind of image meaning, immediate meaning. Love isn't a thing. How exactly does it make sense that this drawing can represent it? Adam. Love. Adam. Love. Just saying, there's a lot going on with pictures like this and how they stand for something that has meaning. A lot more than your chemistry teacher probably told you. There's a lot to think about in the way that we represent ideas, concepts, physical reality, people. And I just want to underscore that I think that there are ways that the experiences that babies have of the world are a more nuanced understanding of physical reality than we have as adults in many ways. When my child was an infant, I felt her cries acutely. I registered them as my own physical pain. So to whose interior did that pain belong? And if my baby thought about her pain as existing everywhere in the universe, was she really wrong? And then when she did discover her own feet and the ability to move them, it didn't take her long to also discover that I had feet, and that she could use my feet as an extension of her own feet. She could find ways to make sure that I moved them exactly the way that she wanted. So to whose body did my limbs belong anyway? A mother and a baby exchange substances, microorganisms, breath, hormones, sometimes straight through the skin. And skin is never neutral. And those exchanges of substance change ourselves as mothers and babies. They change our moods, metabolism, sensory awareness. So is there, in that kind of a system, a logical place to define an edge or an interface? So this is what I mean when I say that some of the things that I know about quantum physics, really feel that I know about quantum physics, really are from my mom.